Hello Algebra 2, today we are looking at Chapter 9, Lesson 4, which is Geometric Sequences and Series. So Serena Williams was the winner out of 128 players who began the 2003 Wimbledon Ladies Singles Championship. After each match, the winner continues to the next round and the loser is eliminated from the tournament. This means that after each round only half of the players remain. The number of players remaining after each round can be modeled by a geometric sequence. In a geometric sequence, the ratio of successive terms is a constant called the common ratio, which r does not equal 1. For the players remaining, r is half. So example 1, determine whether the sequence could be geometric or arithmetic. If possible, find the common ratio or difference. And so looking at this one, we lay out the numbers, we find the differences between the numbers, and then we also find the ratios between the numbers. And in this one, it would be arithmetic because the difference is -7. Example 1, again, determine whether the sequence could be geometric or arithmetic. If possible, find the common ratio or difference. So we lay it out again, find the differences and the ratios. Since the ratios are all the same, which is 1/5, it would be geometric with r equals 1/5 or 0.2. And then the last example of these, determine whether the sequence could be geometric or arithmetic. So we lay them all out again. The differences are not the same and neither are the ratios, so it would be neither. So each term in a geometric sequence is the product of the previous term and the common ratio, giving the recursive rule for a geometric sequence, which is a to the n, which is your nth term, equals a to the n minus 1, which is your first term, times r, which is your ratio. General rule, the nth term, a of n, of a geometric sequence is a sub n equals a1 times r to the n minus 1 power, where a sub 1 is the first term and r is the common ratio. You can also use an explicit rule to find the nth term of a geometric sequence. Each term is the product of the first term and a power of the common ratio as shown in the table. So this table would be a good thing to write down just to help you go through this. Example 2, find the 7th term of the geometric sequence. So step 1, find the common ratio. So you would do your second term over your first term, which is 12/3 in this case, so your ratio would be 4. Step 2, write a rule and evaluate for n equals 7. So your rule is a sub n equals a sub 1 times r to the n minus 1 power. So that's your general rule, so that's a good thing to write down. So then you sub in 7 for n and get a sub 7 equals 3 times 4, which is your ratio, to the 7 minus 1 power. And then you work that out, and your 7th term is 12,288. And then to check it, you can plug in a sub 4, 5, 6, and 7, just to go through the rest of them also. Example 3, find the 8th term of the geometric sequence with a sub 3 equals 36 and a sub 5 equals 324. So find the common ratio. A sub 5 equals a sub 3 times r to the 5 minus 3 power. Here you want to use the two numbers it gives you. And then a sub 5 equals a sub 3 times r to the second power. And then 324 equals 36 times r squared gives you 9 equals r squared. And then you divide, or you take the square root of both sides and you get plus or minus 3 equals r. Step 2, find a1. Consider both the positive and negative values for r. So you plug both of them in. You use positive 3 for one side. This is the positive side. And then you use the negative 3 for the other side. And then you get 4 for both of them. And so then write the rule and evaluate for a sub 8. Consider both the positive and negative values for r. So again, you'll use the negative over here and the positive over here. So then you'll do a sub n equals a sub 1 times r to the n minus 1. You'll plug in 4 for your a sub 1 and 3 and negative 3 for your r. And then for your a sub n, you'll sub in a sub 8 because that is what you're looking for. And so your 8th term is 8,748 and negative 8,747. Geometric means are the terms between any two non-consecutive terms of a geometric sequence. So if a and b are positive terms of a geometric sequence with exactly one term between them, the geometric mean is given by the following expression: a times b, and then take the square root of that. So find the geometric mean of 4 over 9 and 25 over 36. So you would take them times each other and then do the square root, and that gives you 5 over 9. The sum of the first n terms of a geometric sequence, the partial sum s sub n of the first n terms of a geometric series, a sub 1 plus a sub 2 plus a sub n is given by s sub n equals a sub 1 times the quantity 1 minus r to the n power over 1 minus r, and r cannot equal 1, where a sub 1 is the first term and r is the common ratio. So find the indicated sum for the geometric series. Step 1, find the common ratio. Step 2, find s of 8 with a1 equals 1, r equals 2, and n equals 8. So then you plug in s sub 8 for s of n, and then 2 for your r's, and 1 for your a sub 1. So this for this, and the 1 for a sub 1, and your 2 for your r. And then when you work that out, you'll get 255. Find the indicated sum for the geometric sequence. So step 1, find the first term. So you'll take half times 1 minus 1, because your formula is k minus 1, and your k equals 1. So you'll substitute this 1 in for your k. So then you'll get half to the 0 power, and that equals 1. Step 2, find s sub 6. So here's your sum formula. And then you'll sub in s sub 6 for your s sub n. And then your 1 in for your a sub 1. And your half in for your r. And your 6 in for your n. And then you'll work that out, and you should get 1 times 1.96 or approximately 1.97.